Hey folks, we're going to start chapter 12, statistics. I'm going to do notes on a separate sheet of paper because the note packet has a lot in there. Now you should read that, but if you want to follow along with me or write this down on a separate sheet of paper and shove them in that packet or staple it, that's up to you. Okay, here we go. All right. Okay, so a population is a complete collection of all data being studied. My population could be all of Williamsville North. My population could be all nurses in Western New York, or all, women in the United States. So, or all tires coming out of the factory. A census is collecting all the measurements of a population. So if my population was Williamsville North High School and I wanted to take a census, I would have to give everyone a survey from Williamsville North High School. But a census is almost impossible to do. It's time consuming, it costs a lot of money, and usually you can't get it. I know the United States does a census. They're actually doing one this year. I filled out some paperwork for that. But they call it a census, but they will never gather everyone in the U.S. because some people won't take it, or there's homeless people, and, well, you can't give them a survey. So a sample is gathering a few members of the population, and one of the goals of statistics is to get a really good representative sample and then use that data to generalize about the population. All right, number 2, we're going to have observations versus experiments. Well, that has an E right there. So an observation, so you're basically just observing. With an experiment, you're giving humans, I guess, giving them a treatment. Okay, it could be a drug, or, playing music in the background, or some sort of behavioral therapy, something like that, some sort of treatment. So with experiments, you can use the phrase cause and effect. Which means if I was to give somebody a heart medication drug, well, I'm going to have two groups, those that get the heart medication drug and maybe those that get a placebo, or maybe an old heart medication drug. That could also happen too, and then compare them. If my results are significant, then I can say this drug causes this to be lowered, or the blood pressure to be lowered. Observations, you use the phrases, let's see, you could say correlation or increased risk, or your odds of getting sick are something, or there appears to be an association, like there appears to be I know one of the things in the news right now is ibuprofen and the coronavirus. And some people are saying that if you take ibuprofen with the coronavirus, that it's making your symptoms worse. Well, they haven't done an experiment on that. Like, they're not forcing people with the corona to take these medications. So all you can say is we're seeing a correlation. Well, I wouldn't use correlation, but there appears to be an increased risk with taking ibuprofen and the coronavirus. If there is a risk, I'm not sure if they're correct with that statement, but that's kind of what they were saying. All right. Observations versus experiments. Now let's talk about observations only. Usually with observations, you sample people to observe. You need a good representation of your population. So you must sample randomly. Okay. So, maybe put everyone's name in a hat, close your eyes, and start drawing people's names out of there. That's randomly selecting. Or you could choose, have student IDs and have the computer just pick, 50 of them randomly. So random selection is good. Then I can use that to say, all right, well, this is how the kids from Williamsville North feel, because I randomly selected 100 kids. And in that random selection, you're going to have athletes, musicians, honors kids, regular kids, kids in clubs, maybe some kids that are not in clubs, all that. If you don't randomly select, you're going to get biased results. Bias favors one side. So, for example, let's say I gave a questionnaire to the Williamsville North parents and asked them if they were, in favor of maybe the new sports field. Well, you're going to get a lot of parents that have strong opinions on that. And usually it's negative opinions that are going to write in with this survey. So they could be saying, we're not in favor of it because we don't want tax dollars to be increased. So you might get some biased results on that sort of thing. Or it depends on the wording of your question. Maybe your survey's worded like, are you okay with the tax increase that's going to come from the new music wing? Well, when you throw that phrase in there, maybe a lot of parents would be like, oh, yeah, no, we're not with the tax increase. Or if you had a phrase like, in order to have students, take advantage of all the high school music opportunities, and music really improves cognitive learning, are you okay with the new music suite? You'd be like, oh, yeah, well, of course. So it's the wording of the question. So ways of producing bias. And I'll list a few right here. So one, you could, loaded questions on a survey. Or you could have something that's called, response bias. That would be like asking kids if they take drugs, kids, they might lie. Especially the person standing right in front of you. Did you do drugs? You're like, no. You might do drugs every single day. So something like that, your results are going to favor not doing drugs. So that's a bias where they're always going to kind of lean to one side. Or you just have a bad sample, like, something called a convenience sample, where I could only ask my AP students, or only ask the athletes about some sort of school topic. Well, that's lazy. You should want to sample everybody. Okay, so that's that. Now we're going to talk about experiments. All right, so with experiments, you have to give some sort of treatment to the experimental units. Hang on. Can you call your sister back so I don't have conversation on my entire video? Although your conversation was lovely, I'm sure the students were enjoying it, but probably don't want to have it on the video. Okay, you have to give them some sort of treatment. So usually how it works is you have an explanatory variable and a response variable. So this could be like the drug, and this would be the results of the drug. So a lot of times what they'll, and you have to randomly assign the units to each treatment group. Sometimes you'll have a control group. A control group is they receive no treatment. Or it could be 0 milligrams of a specific drug. Or it could be an old drug that you're comparing the new drug to. Sometimes you could have a placebo, control treatment, control group, placebo treatment, placebo group. This is a fake drug or a fake pill. And, well, and then there's something called a placebo effect. Yeah, so let's say I had a headache and somebody goes, wear this copper bracelet and you'll feel better. I put the copper bracelet on. I'm like, yeah, I do feel better. But it was all in my mind, all right, because it's useless, all right? It's not going to do anything. There's no scientific evidence to show that copper works, so they would say that's a placebo effect. And there's something called blind, single blind. That's the patient doesn't know what treatment they are getting. A double blind would be the patient and the doctor does not know what treatment that they are getting. Why don't you want the doctor to know? Because if the doctor developed a drug, you don't want him to try to influence the results of the patient by shaking his head going, you are feeling better, right? Wink, wink. Not that that would happen, but that's, it could. So we're gonna, if you look at this practice exit ticket, I'll do a few of these quickly. So identify whether the study is a survey, observational study, or an experiment. Identify the population of interest. If it's an observation for an experiment, identify the treatment and the response. Okay, so part A, a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys. All right, if they're randomly selecting, sometimes that usually means it's an experiment. That play boys and 20 randomly selected girls that played video games, or that played a game they never played before. The time that took them to reach a certain level of expertise was recorded. That's just an observation, all right? They didn't give them a treatment. They didn't give the boys, I don't know, I don't even know what treatment you would give for this, but they didn't alter anything. They said, here, play this video game that you never played before. That would be an observation. All right, the sample would be those 20 boys and 20 girls. The population would be, all boys and girls. Part B, as your statistics project, you collect data by posting 5 questions on a poster board. That's a survey around your classroom, and you're going to see how your classmates respond to them. So the sample would be the classmates. Do we choose subjects properly to extend these results? Okay, well, no. If you're only interested in your classmates, then you've taken a census of your classmates if everybody answered it. But if you are interested in what the whole building thinks, and you only surveyed your classmates, then no. It was not a representative sample of the population. That was more of a convenience sample, and then the results will be biased. Okay, let's look at G. A study determines whether taking aspirin regularly helps to prevent heart attacks. A large group of male physicians of comparable health were randomly assigned, well, that means an experiment right away, equally to taking an aspirin or taking a placebo. Okay, so it's like, you have your people, and then you randomly assign them to the aspirin group. So this would be a treatment. And then you have them assigned to a placebo group. And then you're going to compare your results. So the explanatory variable would be the aspirin. The response variable would be I don't know, if they lowered the amount of heart attacks that they have. I'm not sure what they're really measuring here, but if heart attack decrease, because I guess they were following them for several years, so it was more of a perspective. Yeah, okay. All right, that's it for this video.